Notebooks today are the slimmest they have ever been. But this decision leads to inadequate heat removal, leaving customers unhappy with performance. To better understand this, let's start with looking at the two ways notebooks remove heat. Passive heat removal occurs as heat radiates from the notebook skin out into the atmosphere. The amount of heat removed increases with higher device skin temperature. But the skin temperature is limited to 46 degrees Celsius to avoid burning users' fingers, capping passive heat removal. Active heat removal relies on built-in fans that remove heat from notebooks by pulling room temperature air from outside the device through inlet vents and blowing it over metal heat sinks attached to the hot processor. Air picks up heat as it passes through the heatsink, and then that hot air is pushed out via exit vents. Active heat removal increases with higher airflow and higher processor temperature. Let's look at two real-world notebook examples. One of the most popular 13-inch notebooks in the market today is a mere 11.3 millimeters thick. Being so thin, there is no room for fans, and it is entirely reliant on passive heat removal, leading to a 10-watt thermal limit. But the processor CPU cores in this notebook require over 20 watts of power to run at a peak frequency of 3.5 gigahertz. With 10 watts supported, the CPU can only run at 1.8 gigahertz, a 50% reduction in performance due to processor throttling caused by the inadequate thermal solution. In addition to the CPU cores, the processor also has an integrated GPU and neural engine. For applications like gaming and video editing, CPU, GPU, and neural engine cores run simultaneously, requiring 40 watts of power for peak performance. But since the thermal solution can support only 10 watts, a 75% loss of performance will occur. In order to increase processor performance, many notebooks add fans for active heat removal. But fans make the notebooks 3 millimeters thicker and generate 42 dBA noise, about the same noise level as a refrigerator. Adding fans does improve the thermal capability, but not enough. Processor throttling still remains. Today's premium 13-inch notebooks with fans have a 15-watt thermal limit, but the processor CPU cores in these notebooks require 56 watts of power to run at a peak frequency of 4.8 gigahertz. With 15 watts supported, the CPU cores can only run at 1.4 gigahertz, a 70% reduction in performance due to processor throttling caused by the inadequate thermal solution. So the next time you buy a notebook, don't just look at its max processor speed. Ask about the thermal solution rating too. It could be the difference between getting full performance value for your money or being forced to settle for far less than you deserve. Frore Systems. Do more.